And you are of course most welcome. This is Project Euler problem number 25, 1000 digit Fibonacci number. So we know the Fibonacci sequence, and the question is quite simple. What is the index of the first term in the Fibonacci sequence to contain 1000 digits? So as usual, brute force solution first and then clever solution second. So brute force first. Generate all the Fibonacci numbers until we find one that has 1000 digits. Nice and easy. So f1 equals 1, f2 equals 1, while length of the string of f2 is less than 1000. Oh, we need something to contain the index as well. So I equals 2. So while the length of the Fibonacci number is less than 1000 digits, we just keep generating new ones. f3 equals f2 plus f1, f1 equals f2, and f2 equals f3, and then I plus equals 1. At the very end we want to print I. That should give us the correct answer. Oh! I put my brackets in the wrong place, haven't I? That shouldn't be there, that should be there. And that gives the correct answer quite quickly, actually. But imagine if we wanted to know the first Fibonacci number with like 1 billion digits. It would take a lot longer. So we need a clever solution. I'm going to get paint up and I'm going to show you how that happens. Okay, so this solution will use the golden ratio and logarithms. The golden ratio is given by the Greek letter phi, and it is 1 plus the square root of 5 over 2. Now, you can have logarithms in pretty much any numerical base you like, but the best one is log 10, for our purposes at least, because that will tell you how many digits are in the number. So let's say we take the 10th log of 450. Technically, the log in base 10 of 450, that will give you something like 2.65, and if we round that up you get 3. But the integer part is always 1 less than the actual number of digits in the number. So even though we're looking for the first Fibonacci number with 1000 digits, we're actually going to use the number 999 in our equation. What equation, I hear you ask? Well, think back to episode 2. I used something called Binet's formula to find the nth Fibonacci number. So it's phi to the power of n minus 1 minus phi to the power of n divided by the square root of 5. We just take the log of this, then we have an equation that we can use, but we need to find n. Now, I tried for about 3 hours. I was literally up until about 3 AM trying to isolate n in this equation. I think it may actually be impossible. So what I've done instead is I've gone on the internet and I found this. So it turns out there is another convergence theorem, another convergence formula, which also uses phi but is a lot simpler. So it's phi to the power of n divided by the square root of 5. So I'm just going to use that instead. So let's get paint back. We'll move that away. We'll get paint back. So we're going to find the log of phi to the power of n divided by the square root of 5 equals 999. Again, the task is to isolate n, but now it's like a million times easier. So, using the laws of logs, let's have a go at that. Now, using the first law of logs, we can transform the left-hand side into this. log phi n minus log times the square root of 5 equals 999, and I'm running out of room, so I'm going to start over here. So let's move log of the square root of 5 over to the right hand side. Log phi n equals log 5 plus 999. Now, using another law of logs, I can move this n over here, and it becomes a divisor. So n times log of phi equals log square root of 5 plus 999. Then I simply divide both sides by log phi. So n equals log times the square root of 5, not log of the square root of 5 plus 999 over log phi, and we've done it. So this is the formula we need, and we're going to write that into our program and find the first Fibonacci number with 1000 digits. So I'll just tidy this up and then we will crack on. Get rid of that. So we don't need this anymore. Oh, you can see the answer. Oh well. Doesn't matter. You can just put that formula into your calculator and get the answer anyway, so it doesn't matter. Nobody watches these videos anyway, so who cares? Right. So I'm going to have... I'm going to import ceiling from math anyway. So from math import ceiling. Then what do we want? So we'll have top, which is oh, we need logs as well, don't we? So is it log or log 10? I'll try log 10. Top equals log 10 of the square root of 5 plus 999. The bottom is log 10 of phi. Now I've got to define phi, haven't I? So phi equals 1 plus 5 to the power of 0.5. Put some brackets around there and divide that by 2. That's pretty much it. Oh, bit of a syntax error there. There we go. And then we simply print the ceiling of top minus bottom. And that, my friends, should do it. Yes. So, there we are. And that is it for episode 25. I'll see you next time for episode 26.